In 1980, 3 siblings were each given $1,000 as an inheritance from a deceased uncle. The siblings agreed to invest their money individually and come back years later to see who had amassed the most fortune. There's a summary right here of how each one of them did. Alan put $1,000 into the bank. Each month he added $62.50 or $750 a year. Bernice invested $1,000 in various money market accounts and earned 12% interest each year, which was compounded annually. Carl, who is the youngest, put his money into technology stocks. Their value climbed according to a parabolic curve until it peaked at $20,600 in 1994. By 2008, his stocks had fallen back to the original value of $1,000. So the first thing I need you to tell me is which history matches which graph. But more importantly, I need you to tell me how you know. Why do you think Alan is a straight line? So Alan's is the line because there is a constant increase. Absolutely. Somebody else tell me. Bernice or Carl? Yes, ma'am. Or you can talk. That's fine. Go ahead. Well, somebody raised their hand and I called on them, but that's okay. Go ahead. No, except I want you to talk. Why do you think Carl is the parabola? Okay, so you're telling me the least obvious way, and that's good. That makes me feel good. Because you know it peaked at a certain time and then came back down to 1,000. That doesn't automatically mean a parabola, but that's a good indicator, right? What's the most obvious way you know it's a parabola? It says parabolic curve right in the words. Okay? So what do you want to put for the reason? Parabolic curve? Right where I underlined? Right here? It's okay. So what about Bernice? So if this is Alan and this is Carl, that leaves this as Bernice. Right? So you need to know what shape that is. Swoop. We have not studied any swoop parent functions this year. So we don't need to say swoop. It's a skateboard ramp. Also, we have not studied any skateboard ramp parent functions this year. You guys are all saying very interesting things. Some a little bit more interesting than others. Some a little less interesting than others. It is exponential. It is exponential. How do you know? A percent increase. It's increasing by a certain percent, not a constant amount, but a percent of the amount. Okay? So we're going to let X be the time in years since 1980. So write function rules for each of these functions to figure out how many or how much money each sibling had after X years. Now you know I like it better if you all take turns instead of all trying to speak at once. You guys usually have the easiest time writing equations of lines. Partially because you've been doing it the longest. So what's Alan's equation? 1000 plus 750x. Where'd that come from? Alan started at 1000 and he had added $750 per year. That's perfect. Very good explanation. Nothing? We can't do anything with the 6250. Some of you tried to multiply that by x, except x is years, right? He added 6250 a month, didn't he? So we would have to convert that to years, which is what they did for us in the sentence. Okay? So, Bernice or Carl? Most of you have an easier time with Bernice writing her equation, because that is exponential. We just got finished doing that. And just as a very quick reminder, this was the form that exponential functions were in, right? A plus b to the x power? Or excuse me, a times b to the x power? What's a? The starting point, right? What did he start at? Or she? 1000 times, what's b? It's the common ratio, right? So some of you just said 0.12, and unfortunately that's incorrect, but it's close. What is it? Why is it 1.12? Because it's increasing 12% every year. Do you remember that? You remember us having that conversation? 2 people. Excellent. Okay. You don't get what part? Because we have to multiply it by its original value, by the 100%, and then we're adding 12% each year. So it's 1.12. Remember we had that whole conversation when we did those 2 problems. One was on the top, one was on the bottom, one was increasing, one was decreasing. It was about a car. So if we're decreasing 12% a year, this would actually be 0.88, because it's 100 minus the 12% it's decreasing. If we're adding 12% every year, then we add it to the 100%. If we're losing 12% a year, then we subtract it from the 100%. Do you remember that? Still not the person I'm asking. Well, you're the one that asked the question, so I'm hoping you'll answer. Are you lying? Great. So what about Carl? It's a parabola, right? ax squared plus bx plus c is the standard form, right? As far as I can see, that doesn't help us at all. I mean, you guys might know a way. If you do, please let me know. I'd love to know it. How many points does it take to graph a line? 2. We could have figured out 2 points, right? From the problem, from what they gave us. How many points does it take to graph a parabola? 3. Do we have 3 points? Could we let our calculator do the work for us? Wouldn't that be funner? Yeah, I don't care that that's not a word. I really don't. Where are we going? I need a new document. That is a spreadsheet. What goes in our spreadsheet? Years and money? Why can't it be money in years? The amount of money depends on your years, right? Okay. M-O-N-Y. Okay. So now that I have my labels in, now what? What did you say? Put in information. All right, tell me information. Okay, so what do I put in? For years?
For money. First year. Or 0 years because it's starting out.
Why don't I put in 180 though? Or 1980?
Because it's the year. Oh wait. It's not how many years.
It's not the year, it's the time in years since 1980. So in 1980, how many years had passed since 1980? So 0. I gotta have at least 3 points. Where did you get 14? Oh. In 1984, he had 21,000? Oh, pardon, 20,600.
Unless you add the 1,000 to it.
Yeah, nope, we don't.
And then in 2008, which would be,
In 2008, it would be 28. Very good.
it was back to 1,000.
Loser. Wait, did I say that out loud? Okay. That's not very nice, I'm sorry. So now what? So add a page, control page, data and statistics page. What goes down here? Years. Where the heck is my cursor? Yeah, I know, not that kind of cursor. Thank you, though. Thank you for volunteering. Money? Now what? I could analyze my graph, so menu analyze. Yes, I would do a regression. What kind of regression? Quadratic, right? Bam! Math. Yeah, our calculators are smart. We're smart enough to be able to put stuff into our calculator so it tells us the right thing, right? So negative 100 x squared plus 2800 x plus 1000. Okay. Check the equations using a graphing calculator with the domain of x is less than or equal, 0 is less than or equal to x is less than or equal to 28. What? What do they want us to do? So control page. Is that a graph page? What goes in f of 1? 1000 plus 750x. 1000 times 1.12 raised to the x power negative 100 x squared plus 2800 x plus 1000. So if this is supposed to look like this, mine is clearly broken. Oh, I have to change the window, right? Window, okay, menu, window. Settings? Should I just zoom out? No, doesn't it give me some specific settings? What's my domain supposed to be? 0 to 28, right? So my x min should be 0. My x max should be 28. How should I count? How did they count? 14s. Do I have to count the way they counted? No. But if I'm trying to get my graph to look similar, it might be nice. Y min, 0. Y max, where does it go up to? 20,000. But we know we have to go higher than that, don't we? Because this is going to go higher than that to begin with. So do you think 25,000 is safe? Okay, we'll go with what you say. How are we counting? 10,000s? Ah, that's beautiful. We did amazing. Why do you think we would go do Control T now, Kelsey? Because we got to fill in a table, don't we? Okay, it says complete the table. So let's do Control T. Get our table pulled up. Now, I put mine in order on purpose, right? F of 1 is A, F2 is B, and F3 is C. Like, I thought about it. I put, just put them in order. Okay? So after 5 years, how much does Alan have? 4,750. After 5 years, how much does Bernice have? 1,762 and 34 cents. And Carl? Jiminy Christmas, Carl already has $12,000. What about after 10 years? 8,500, 3,105, and 85 cents. I don't know why I put a comma. Sorry about that. And Carl has $19,000. Geez, Carl. What about 20 years? Ooh, Alan's starting to... I almost just said it, get high, but that's not what I meant to say. $9,646.29 is what I want to say Beatrice. Bernice has. And Carl has $17,000. And after 25 years, $17,010 and 8,500. So at the end of 5 years, who has the most? Look at these three numbers. Which one is the highest? Jiminy Christmas, yes. You guys are freaking me out a little bit here. I have to admit that. After 10 years, who has the most? After 20 years, who has the most? 25? Alan. It is given, it was told to us that Carl had $1,000 after 28 years. How much did the other siblings have at this point? So we can just use the table still? So after 28 years, Alan had 22,000 and Bernice and 90 cents or so. If you want to get technical, it's really 87 cents, isn't it? Because you can see that the entry right there, it just rounded it for us right there. So wait, 3 more years and Bernice has the most money? Heck yeah. Good job, Bernice. Let's go and relabel this graph because I don't want to have to keep flipping back and forth to the graph I already have labeled. Who has the line? Alan. Who has the parabola? And who has the swoosh? Is that what you called it? A swoosh? A swoop. Excuse me. A swoosh is clearly wrong. It was a swoop. Okay. After approximately how many years did Alan and Bernice have the same amount of money invested? And what was that amount? So we're trying to find Alan when Alan and Bernice had the same amount, right? What are we looking for? Oh, the intersection. So we just guess? Is that the best way? No, I know. I love how you say it. No. Like I'm some sort of idiot. Thank you. How do we figure it out? So let's make control table, make the table go away. We're going to analyze my graph. You need to be careful because something different happens here than what you're used to. Did you get rid of the table? What? Let me see it. Did you already hit menu? I know. That's why I was saying, wait with me. I have to show you what's happening that's different. Did you hear me say that? Because I could play back the recording. I'm just saying. Intersection. What does it normally say down here when we go to look for intersection? Lower bound and upper bound, right? Now it's saying graph. Why is it saying graph? Didn't I already enter my graphs? I have to tell it which two graphs I want to use. When I hover, which two am I using? Alan and Bernice. So the line, so go find the line and click on it. Then it says second graph. Bernice is the swoop. Then my lower bound shows up. Okay? You have to tell it which two you're talking about first. So there's my lower bound. There's my upper bound. The point that I got on my graph was 27, 2.12 e plus 4. What? I think mine's broken. You realize why I say that to you, don't you? Because that's what I hear. When you get something you don't expect, clearly your calculator's broken. Okay? It's not broken, you just have to know how to read it. What does this mean? 2.12 times 10 to the 4th. Well, if I multiply this by 10 to the 4th, I get that. So it's 21,200. Holy cow. What does that mean? At 27 years, they both have $21,200. Very good explanation, Hannah. See, I know you know what you're talking about sometimes. So what about 6? After approximately how many years did Alan and Carl have the same amount of money? Oh, so do the same thing but with two different things on the calculator? Two different curves, lines, whatever? Menu, analyze, intersection. Which two am I talking about this time though? The parabola and the line. So there's the line. There's the parabola. And there's the intersection right there, right? So there's the left, there's the right. Now this time, that's kind of hard to see. So I'm going to hit Control and the middle click. I'm going to drag this up here where I can read it. What I got was 20.5, 1.64 e plus 4. Tell me what that means. So 16400, 16,400. So what was this amount? When did they have the same amount of money and what was it? At 20.5 years, they both had $16,400. Good. 20.5 years, are you okay with that? What's another way to say that? 20 years and 6 months. Very good. Okay. After approximately how many years did Bernice and Carl have the same amount of money? And what was that amount? Same thing? Okay. Menu, analyze an intersection of the swoosh. Okay, let me, oh no, swoop. It's a swoop. And the parabola, right? And they cross right here. And once again, it's going to be difficult to read. So I'm going to control click that point and drag it down just a little bit. 22.7. 1.31 E plus 4. 22.713100. So that's, whoops, 13,100. So at 22.7 years. Yes, ma'am.
Can you send Dominic a link to the office, please?
Can he come in just a moment?
Probably just like right before the daughter gets fine too.
Okay, thank you. 13,100. So at 22.7 years, they both had 13,000. Too many Christmas. I can't round my numbers today. $13,100. Are you okay with 22.7 years? What's another way to say it? Really? 20.5 is 20 years and 6 months, but 22.7 is 22 years and 7 months? It's not, is it? Isn't 0.75 a quarter of a year? So that would be 9 months? Okay, so it would be closer to 9 than it is to 7. Don't be fooled by that. One of these problems can be solved algebraically. Which one do you think it is? Okay, guys, for the record, it's saying one of these three up here. Not just one person's. It's saying which one can we find the point of intersection with. Alan and Carl. We've done something like this before. So let's solve it algebraically. What is Alan's equation? And what's Carl's? And if we're trying to find the intersection, what are we doing with these two equations? We're setting them equal to each other, yes? So how do I solve this equation? Subtract 1,000. Oh, that was nice. Gone, gone. Now what? Subtract 750. X. 0 equals negative 100x squared plus 2050x. So I could use a quadratic formula if I was just wanting to put myself into pain. Or I could factor out an x from each term, couldn't I? Could I factor anything else besides x out? Probably. Let's just go ahead and factor out an x for now. If I have two numbers that multiply by each other and get 0 as the answer, what has to be true about one of those numbers? One of them has to be 0. Let's make both of these numbers equal to 0 and figure out what that gives us. I should say at least one of them has to be 0, right? So one of my possible answers is x equals 0. if I divide both sides by negative 100, I get x equals 20.5. OMG. Wait, where did this other answer come from? Yeah, look at the graph. Aren't they both the same at 0, 0? I mean, 0, 1,000? Right? Any questions? This is the kind of stuff we're going to be looking at this week, so come prepared. Okay? Come prepared. I hope you have a great day. I hope you have a great day. Kingston out.